Hello. Yes, so in this lecture, I'm going to discuss about a very interesting thing of digital electronics, which is known as shift register. So what is the purpose of shift register and what are the different categories and how this work? All these things I'll be covering in this lecture. So first of all, what is shift register? Shift register is nothing but it's a combination of some flip-flops and that can be used to store some binary number. Okay, suppose we have some number, some binary number, suppose 1010, and you want to store this particular numbers 1010, this particular combination you want to store. So we need to use one register. Okay, and the most important thing is that as register is nothing but the combination of some flip-flops, and the problem is given as 1010. So four binary bits are there, which I need to store. So in this case, I need to use 4 flip-flops. Okay. So in this register, how many flip-flops will be there? 4 flip-flops will be there. Okay. So the number of bits I need to store in that particular register, I need to have that number of flip-flops. Okay. Now, the flip-flops can be connected in the register such a way so that the binary numbers will be entered into the register and possibly it will be shifted out. Okay. Now, based on the different configuration of input and output, this shift register is divided into 4 categories. The categories are serial in, serial out, parallel in, serial out, serial in, parallel out, and parallel in, serial out, parallel out. Now, what is serial in, serial out? So in, serial out, the data will be entered serially and the data will also be taken out from the register serially. For example, suppose we have this particular data 1010 that we are applying in this serial in, serial out register. So from the output of this register also we'll get 1010 and that will get serially. So that's why serially we are inputting the data and serially we are getting the data in the output. That's why this is known as serial in, serial out. Now the next category is parallel in, serial out. Parallel in, serial out means suppose if this is the example 1010 if we take, then 1010 we need to give at the same time in the register and one by one data will be collecting from the output. So parallelly we are inputting the data and serially one by one we are collecting the data from the output of the register. That's why this is known as parallel in, serial out. Now come to the third category that is known as serial in, parallel out. So serial in, parallel out is we need to enter the data serially. Suppose for example 10101. That data we need to enter serially and parallelly we need to collect it. So we need to collect the data like 0101 parallelly at the same time. Okay, this is a serial in, parallel out. And in parallel out, in this category, what you need to do, if we have this example 0101, these all 4 data we need to give at the same time, and at the same time only we need to collect this all this bit in the output. Okay, at the same time, at the same instance. Okay, so this output will be 0101. Okay, so this is parallel in, parallel out. So these are the 4 categories. Now I'll discuss about each of the categories. Now, first of all, serial in, serial out. So as it name, what it is indicating, we need to enter the data serially and we need to collect the data serially from the output of the register. So here one example is shown where 4 flip-flops are there, which are combining a serial in, serial out register. Okay, the combination of these four flip-flops is constructing a serial in, serial out shift register. Okay, now you have to remember one thing. In this register design, we need to use only D flip-flop. We need to use only D flip-flop. We cannot use the other categories of flip-flop like T flip-flop or maybe JK also we cannot use. Okay. Generally, we'll be using D flip-flop. Why D flip-flop? Because in D flip-flop, if you give 0, you'll get 0. If you give 1 as an input, you'll get 1 at the output after applying the clock. So you know in case of flip-flop how it works. If you give input to the flip-flop and if you apply clock, then only you'll be getting the output. You have to apply clock. So in case of a sequential circuit, the clock is so much important. Okay. So generally in this shift register, we'll be using D flip-flop. Okay. Now in this case also, in this particular configuration, what I have shown here, this serial in serial output shift register, you can see four flip-flops are used. So it's a it will be used to transfer 4 bit of data. Okay. Now suppose we can take one example. This is the example you can take. We want to transfer this particular data 1010. Okay. 1010, we need to transfer the data. Okay, we need to shift this data by using serial in serial output, serial output register. So how it will work? So initially you can consider that all the flip-flop outputs are 0. So here you can see in Q0 the output is 0, in Q1 the output is 0, in Q2 output is 0, Q3 output is 0. So initially you can consider all the output of the flip-flops are 0. Okay. Now you have to give this input of 1010 in the input terminal of the, that is data input. Okay, which is shown here. This data input terminal, you need to provide this input and you need to get the output after applying the clock. Okay, so what we need to do in serial out, first of all, we need to start from the LSB bit. So 0 you need to first enter here. Okay, 0 we are entering. Now, after applying the first clock, what will happen? Because this clock terminal is connected to each of the flip-flop. So after applying the first clock, what will happen? Immediately my output will be changed, or according to input, I will get the output. As my input is 0, so what output I will get in Q0? The output will be 0. Means it is remaining same as it is. Previously also the output was 0. Now in this case, as the input is 0, the output will be remain same. Now in D1 also, as the input was 0, the output will be 0, and similarly in D2 also output will be 0, in D3 also output will be 0. So after the first clock, what is the Q1, Q0, Q1, Q2, Q3 values? That is nothing but this is 0, 0, 0, 0 and 0. So what does it mean? So from Q3, what output we are getting? We are getting the output of 0 from this serial in, serial output register. So after the first clock, the output is 0 only, that we are collecting from this terminal, from this output terminal, or from this Q3 terminal. Okay. Now apply the next input, that is 1. So if you can remember, we have already applied 0. Now we need to go for the next bit, that is 1. Okay. The second bit we need to apply, that is 1 we need to apply. Okay. So we are applying 1 here. Now, if you can remember the previous stage condition, if you can remember the previous stage output actually, the outputs were, if you can remember, this was 0, this was 0, this was 0, and this was 0. So we can write it down also. So this output was 0, this output was 0, this output was 0, this output was 0. Now my input is 1. Okay, and I'm applying the clock for the second time. What will happen? As my input is 1, and as you have applied the clock, immediately your output will be 1 for this 0th flip-flop, or for this flip flop. Okay, for this flip flop. Now, if you come to the next flip flop, that is this flip flop number 2. Actually, first one we can consider as flip flop number 1. Second one flip flop number 2. This flip flop number 3. This flip flop number 4. So let me rectify this thing. Previously, I told this flip flop number 0. It should be flip flop number 1 as it is indicated by 1. Okay. So in this flip flop, you can see if you apply input 1, then you are getting 1. But for flip flop number 2, what will happen? Because if you can remember the previous, this value was 0. So as you have 0 here, the output will be 0. And if you can remember, as the previous output was 0, here the output will be 0. As the previous output was 0, in Q3 the output will be 0. So after the first clock, you see here, ultimately from here, still what we are getting 0. Okay. So in the previous clock also we got the output of 0. Means after the first clock, we got the output of 0. And after second clock, also you are getting the output of 0 in this shift register. Because this is my, ultimately, this is my output of this register, serial in serial output register. Okay. Now come to the next bit. So that bit is 0. Again, you need to apply 0. So you apply 0 in this input terminal, this 0, and you are applying the clock here. That you are applying the clock for the third time. Okay. Now what will happen? As your input in this first flip flop is 0, your output will also be 0. This is the principle of D flip flop. Now, if you can remember here, the output was here in this stage, the output was 1, if you can remember. Okay, so in order to make you understand in a proper way, let me use red color to show the previous outputs. Okay, and after applying the clock, what output I am getting? To show that one, I am using some other color. Maybe I can use some black color. Okay, so if you see here, the previous outputs were this 1, then 0, then 0, then 0. Now, after applying the clock for the third time, and if you inputting 0 here, this input terminal, what will be the output that I will be writing now? So now, as your input is 0, your output will also be 0. Now, as your previous output is 1, now your next output here, it will be 1 for the second flip flop. Now, for the third flip flop, as the previous input is 0 for the third flip flop. So now what will be the output? The output will also be 0. Now come to the fourth flip flop. You see in the red color it is shown 0. So as 0 is there in the input of D3, you will be getting 0 in the output of this fourth number flip flop. This is the principle of D flip flop. If this is input is 0, output is also 0. So it means after third clock also you are getting 0. Okay. So this updated thing we can write, which will be used for the next stage. So you can write it down what updated value we got. This is 0 we got in this stage, 1 we got in this stage, 0 we got in this stage, 0 we got in this stage. That I have used red color to mark that. Now we need to take the fourth bit, that is your 1, that you need to input here, and you need to apply clock for the fourth time. Okay. Now see, now your input is 1 for the first flip flop. What will be output? So I'll use different color for the output for the current stage. So as your input is 1, your output will be 1. Your output will be 1. Okay. As your input is 0, your output will be 0. In third stage, the input is 1, so output will be 1. Now come to the fourth stage or fourth flip flop. Input is 0, the output will be 0. So you can see what are the inputs I am considering, that is written by red color, and just now after applying the clock, what output I got, that is shown by black color. Okay, so what does it mean? After applying the fourth clock, my output is 0. Still, whatever data I have applied, that I didn't get. I applied the data of 1010, still I didn't get. I need to apply few clocks to get the entire data. Now, what you need to do? Now, after that, you no need to enter any further input because what data you have applied 1010 that you want to collect from this site. Okay, so you no need to further input any data here. So by default, you can consider it is coming as 0 that you can consider. The input data you can consider by default because we don't have any other value in this site. So you can consider by default, this is coming as 0. Okay. Now, if you can remember the previous stage, these outputs, we can write it down. That is shown by the black color. That will be easy for you to understand. I can use red color. The previous stage output, this was 1. This was 1. The next one is 0. Then the next one is 1. One is 1 and next one is 0. Okay. The next one is 0. So this is all the previous stage output I have written. Now I need to apply the clock for the fifth time. And I am inputting the by default data I am considering at 0 because I don't have any other further data in the left side. So I can consider it as 0. Now see, as you are considering 0 here, what output you are getting from this stage, that is 0 only. And so I can use black color again. So this output is 0 only. Okay. As the previous output, this is 1. So what output I will get from this stage? From stage number 2, from here I will get the output of 1. And from stage number 3, I will get the output of 0 because here previously it was 0. And from the stage number 4, that is flip-flop number 4, what output I will get? That is 1 only because this stage is 1. Okay. Understood? Now I got 1. Okay. Now, now you apply the clock for the sixth time. Okay. Now by default, I'm considering as I don't have any other bit, I am considering it's as 0. So till now, what output I got from the previous stage that I can write it down here. I can use red color to write those outputs. So you can write here what are the previous outputs you got. Here you got 0. Okay. Here you got 1. Here you got 0. Here you got 1. Try to understand what I got in the previous stage that I used black color. Now, when I'm writing these values for the current stage, I'm using red color. So this value I have written here. 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 Now, after applying the clock, what will be the output? That I shall use black color to represent. So 0 is your input in the first stage. So you'll get 0. Now 0 is your previous stage, this output. Now you will get 0 here. As 1 is your input, you will get 1. As 0 is your input, you will get 0 here. Okay. So after applying the sixth clock, what is the output you are getting? You are getting this particular pattern and this output is 0. Okay. So till now what we got, you can check. We got 0. So we can use some different color to show. Till now we got 0. We got 1. And in the previous stage, we got 0. So if you can remember, the data was this one. The data was this one. This particular combination 1 0 1 0. Until now we got these 3 bit. This 0, then 1, then 0. See this 0, then 1, then 0. These 3 things we got. And if you apply the clock for the 7th time, suppose 7th time you are applying the clock. Okay, then what you are supposed to get? If you just draw one circuit here, this is the clock you are applying to each of the flip-flop and see the input. Now again, I can consider this my input is 0 and before going to the discussion of this particular stage, let me write down the previous stage output first. Then it will be easy for me to understand. Okay, so previous stage output is 0. You can write 0. Next one is 0. The next one is 1. Then the next one is 0. This was my previous stage output. Okay. Now, after applying the clock, what output I am getting, that I am writing by using black color. So 0 is my input. So here I'll get 0. So this 0 is coming here. It means that I'll get the output of 0. This 0 will come here. I'll get the output of 0. This 1 is coming here. I'll get the output of 1. So after 7th clock, you see that you have got the entire thing what you have applied serially in the input. Okay. Okay. What data you have applied in this shift register, that is 1010. After applying the 7th clock only, you got this value, that is 1, 0, 1 and 0. Okay. So if you have 4 number of flip-flop, after applying the 7th clock, only you will be getting the data, whatever you have applied, that entire data you will get. As this particular case, we have used 1010 in this particular case. So after applying the 7th clock only, we got the entire bit. So that is 1010. Enter this bits pattern we got. Okay. So we had to use 7th clock to get the entire all the bits. What we have applied in the input of the shift register. So this is the principle of serial in, serial out shift register. Okay, thank you.